Hello and welcome back to the channel, and this is the second part of 2D platform game in Unity, and we left off with a basic movement for our player, for now represented by a square, and we can move left and right and perform jumps. So to move further, we have to implement one thing, mainly. As you can see right now in our code, what we do is we read the input directly from the input class for our game to interact with the input. And this is fine, and we could continue this way, but actually when you're building games in Unity, there's a special new input system that you might want to use to actually separate the input from your code, right? So in that way you can make it work with many different devices providing input, like for example touchscreen or virtual joystick or keyboard or gamepad. So we'll start with that. So actually the input system is a separate package that we have to add to our project. So go to Window, Package Manager, bring that here. Here make sure to actually choose Unity Registry and then move to search, and we're going to search for input system. And let it load. Oh no, not in project, but Unity Registry, sorry. Here we have to choose the Unity Registry. And now let's search for input system. And here we have the input system, current version, released on November the 3rd, 2022, is 1.44. And I'm gonna simply click install. It will take a while. Okay, and after the installation, you're gonna be asked to restart the editor. So just click yes. Okay, after the restart, you can just close the package manager. Okay. And then what we have to do is actually create the input action asset. So that's going to be the asset describing what actions our player can perform and what buttons are assigned to those actions. So just go to the project, and here in the assets folder, I'm going to go create, and I'm going to search for input actions, which is here at the bottom. And you can see that this is this white icon with the blue thunder, which is representing the input actions. So I'm going to just name it player actions. Okay, double click it. It's gonna create a new window. And here you can see that this is divided into three main fields: action maps, actions, and here you're gonna have inspector with some options, right? So I'm gonna create action maps, which is like a set of actions, and I'm gonna name this just player. Okay. You can click save asset, or you can click here. Here you have the save asset button to manually save the input actions asset, or here you can click autosave and it's gonna detect any change and save the asset automatically. So in the actions, I'm gonna just click and delete the action and create first action and name it movement. Then again, I'm gonna click and create another action, and I'm gonna call this jumping action. Okay, so now we have to describe our actions, and here we have no binding, so I'm gonna also delete that and then click on a plus here next to the movement, and I'm gonna go add positive negative binding, and I'm gonna name it horizontal movement. So here we choose the type of our action, and in our case that's gonna be 1D axis because we're only interested in the movement along the x-axis. Moving from the -1 to 1 is fine. Our character is not gonna move vertically, at least for now. We will move vertically only by using the jump. Okay, so I'm also gonna change the action type here from button on our movement to pass-through, and the difference is that pass-through is being passed directly to the device to handle. Okay, and then we have the horizontal movement. This is pass-through. Basically, you always choose pass-through whenever you're interested in some kind of continuous movement. And this makes sense because as long as I am holding A or D, in our case, I would like my character to move in that direction. Otherwise, you could stay on the button, for example, when you are performing one kind of action. So, for example, opening the door, right? You wouldn't like your character to just hold some kind of button for amount of time. You'd like just it work just by clicking F button, for example, once. And here I can add the path, meaning the direct button from my keyboard that I would like to use for that. And I'm gonna open it up, click on listen and press A and choose A from keyboard. Right, so if you click, you can search here for a button just by providing input here, but I find it more comfortable to just click listen and then provide the button I'm interested in. And I'm going to choose keyboard. I'm going here for the positive. I'm going to do the same, so click listen and press D. Then jumping. Jumping is actually that kind of fire and forget one time press action. So I'm going to leave it at button. And here I'm going to click listen and press space. And that's it. We basically have our player actions handled here. So we can just save asset, or if you have autosave, you don't need to, and just close it. Okay, and what I would like to do is for us to actually use that player actions asset on our player, we're gonna add another component here, and this is player input component. And here you have different options, but for us, what will be the most interesting is the actions asset that we have to provide here. So you can click, and just choose player actions. And then there's a behavior. So what kind of behavior you would like to be responsible for handling the key presses. And there are a few different options. As you can see, you can use just send message, which will just fire some functions on a given script. But I'm going to change that to invoke Unity events. Okay, and I believe that there's a difference between send messages and broadcast messages. Meaning send messages will only send the information about given button press only to the components on that object in a hierarchy, so only to the components that are in a player, and then broadcast messages can be used to actually broadcast that information also to other game objects in your hierarchy, right? but I'm going to go with invoke unity events because for me that makes the most sense. And here I can drop down the events, and there's the player, which is actually representing that action map that we defined. And then I can find the two actions I defined, so the movement and the jumping. Okay, and what we could do is we could define the callbacks for both those actions inside of our player movement, but I find it really good to kind of separate it and create another script just to handle the input. So I'm going to call this input manager, and I'm going to fire it up, wait for it to load. Okay. And here we're gonna define some stuff. Basically what we have to define are the functions that we'd like to call whenever given button or given action is being performed. So I'm gonna create public void, and I'm gonna call the first one that's gonna handle the left-right movement on movement changed, and the parameter here is the input action callback context, and I'm going to just call it context. And the same we're gonna do for jumping, and I'm gonna call this on jump. Input action callback context. Yeah, and for now let's just add some simple debug logs to see whether it works. Move jump. Okay, so we have that saved. Of course, there are a few things that we have to do. First thing is we have to go to a player and then drag and drop our input manager onto that game object to actually make it work. And then in our player input, here where we have the events and player action map, we can just ignore those actions at the bottom. You get these like just for free. And as you can see, they are not in our player action map. And here what you can do is just add plus, drag our player game object here, and from here we're gonna choose input manager, and here at the very bottom with the dynamic callback context we have on movement changed, and do the same here. So let's drag it again here and choose input manager on jump. Okay, let's save everything. Let's fire it up. And let's see whether that actually works. So I'm pressing space, and as you can see, our character is still jumping because of the code in the player movement script, but we also have the information about the jump being performed in the console, which is coming from input manager, meaning our new input system is working. And the same if I'm gonna move left and right, you can see right here that the move is being on move callback is being called. So this is great. Now, one thing we have to do in our code is to figure out how to communicate between our player movement, right, and our input manager. So what I'm going to do is I'm going to just create a reference to the input manager here, because our movement is dependent on the input, so it makes sense to actually create the input manager inside of player movement. So I'm gonna just create private input manager, call this input manager, and I'm gonna do this here. So input manager get component input manager, and actually, since this initialization that we see right here is for now only initializing the fields relying on the components from the very same game object, meaning we don't reference any other game object here or any other class, I can just move this to awake. Okay, we have that. And then we have to basically read some values from the input manager to perform our actions. So let's go back to the input manager. And here I'm going to define vector2, and I'm going to make it public. I'm going to call this input velocity. And we're going to make it so that everyone can get it, right? But no one can set it. Why so? So we're using the getter setter pattern here. Basically, this whole code that you see right here is the same as if I would write something like public. Let's just do something like this. Oops. Private vector2 input velocity, and then public getter would look like get input velocity vector2 input velocity, and private void set input velocity vector2 velocity, and then input velocity is equal to velocity. Okay, so instead of creating separate setter and getter and making this private and public, I'm just making this in a property, right? And this actually makes sense because the input should be provided directly by the user via a given device or by the input system, but everyone else should get the value of that, especially the player movement script. So let's actually read our values from there, and let me check. The movement, horizontal movement, right, everything should be set up correctly. So let's read the values, and we're gonna make it like so. Float horizontal input is gonna be equal to context read value float. Because we're moving from -1 to 1, we're gonna get the values as a float. But also we need to check in the context whether the action was actually performed. If not, just return. So maybe let's start with that and only then read the value. And then we can update our input velocity and set it to new vector with horizontal input and 0 on the vertical. And then in case of a jump, we can just do the same check. can return, and then set the input velocity to plus equal new vector 2, 0, and 1. Right, and this is actually really cool because if you take a look at that, we're moving from -1 to 1 on our horizontal value, and then moving in a vertical value while performing our jump also by 1. So here we're only reading like the plain normalized values, and then there's a case of what we'll do with them in the player movement script. So here everything is staying pretty much the same, except for the change here. So we're not reading that anymore, and we're not reading the input here. Okay. So how do we actually read the velocity right now? We're gonna just create new vector where x is equal to input manager input velocity x times speed, and then the y is equal to input manager input velocity times y times jump force. So here now in one line we can check for both the x movement and jumping. Let me just... Okay. So that's one thing. The other thing is what should happen if we're not grounded. Well, then we should carry on and remain in a given velocity. So I can do rigid body to D velocity. Okay, so here we're handling both cases of us being grounded and not grounded. And as you can see right now, we're only storing the velocity in the vector2. This is like the class that we created, and we're not applying these into the rigid body, because when working with physics, meaning rigid body or rigid body 2D, you should actually apply the calculated physics value into the fixed update. So let's use the fixed update, and here let's say if a rigid body 2D velocity equals velocity. Okay, so we're reading our values from the input manager, right? And here we're multiplying them by the values stored on our player movement. And then if the our character is not grounded, we just continue with the very same velocity that we had in the previous frame. So let's see how that works. Close this and hit play. Okay, we can move left and right. What about jumping? And you see something strange here. If I press space once and stop pressing anything else, we're just continuously jumping. So that's kind of an issue. So let's see why that might be. Okay, if we press jump, we increase our input velocity and set the value of y to 1. And this is then applied to velocity every frame. But there's no place where we reset our input manager and reset its y value back to 0 to actually inform that the jump was performed and the next one shouldn't be performed. So let's create a very simple function. Let's call this public void reset jump. And I'm going to just say that whenever this is called, the input velocity should be reset to have the value of input velocity x and 0. Oops, 0. So that function is going to reset the value for the jump. Then we have to decide where to use it. Basically, once the value of the jump has been applied to the rigid body, and we know that the jump is being performed, we can reset that. So I'm going to say if rigid body, if velocity y is greater than 0, then get the input manager and reset the jump. And now you can take a look how it works. So I'm moving and now I'm pressing jump once and I'm pressing jump once again. And you can see that the value of the input is being reset properly after applying the vertical velocity. Yeah, so that's it for today. We successfully moved to the new input system, and as possibilities and actions of our hero, our main character, to grow, for example, like stuff like gathering things or fighting the enemies, then we will actually grow our action map and we'll grow our input manager. But for now, this is great. We move to the new input system. So thank you for that, and I'm going to see you in the next one. Goodbye.